7 days before Kay's birthday, Carlo decided to give her white roses according to the Fibonacci sequence. On day 1, which is 7 days before her birthday, he gave her 1 white rose. Then on the next day, 1 white rose again, then 2 roses, then 3 roses, and so on. How many roses did Carlo give Kay on her actual birthday? We are talking about a Fibonacci sequence, and we are looking for a certain term in this Fibonacci sequence. The question is, what term is it? Does this mean that we are looking for the 7th term? So let's analyze. He started with 1 rose, and then 1 rose again, and then 2 roses, and then 3. This is 7 days before birthday. Okay, so we have no choice but to complete these terms up to the day or the birthday of K. So the next term will be 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13. Okay, this is the 7 days before the birthday, 6, 5, 4, 3, 2, 1. So this is the day before the birthday. So therefore, on the actual birthday, he gave her how many roses? 8 plus 13? 21. He gave her 21 roses on her actual birthday. A rocket rises 25 feet after 1 second, 90 feet after 2 seconds, 155 feet after 3 seconds, and so on. If it continues to rise at this rate, how many feet will it have risen after 30 seconds? Let's observe if this is an arithmetic or a geometric sequence. First, we have 25 feet, followed by 90 feet, and then 155 feet. So let's see if there's a common difference. 90 minus 25 is actually 65. 155 minus 90 is also 65. Therefore, it is an arithmetic sequence. So we will now proceed with an arithmetic sequence. Therefore, a sub 1 is equal to 25. The common difference is 65. Then, if it continues to rise at this rate, how many feet will it have risen after 30 seconds? So, n is equal to 30. And so, what is a sub n or a sub 30? That's the question. Our formula is a sub n is equal to a sub 1 plus quantity n minus 1 times d. So, a sub 30 is equal to a sub 1, 25, plus n minus 1. We can now subtract right away. 30 minus 1 is 29 times d, which is 65. Or 25 plus 29 times 65 is 1,885. Then adding 25 plus 1,885 is 1,910 feet. Therefore, after 30 seconds, the rocket has risen 1,910 feet. A ball dropped from a height of 20 feet bounces up a height which is 4/5 of its previous height. What is the total vertical height traveled by the ball before it stops? Let's analyze this problem. The ball is dropped from a height of 20 feet. So naturally, it will bounce up. Okay. If it will bounce up 4/5 of this previous height, 4/5 of 20 is 16. And then it will go back down again the same distance, which is 16. And then go up, okay, 4/5 of 16, which is 12.8. Yan. Then it will continue to bounce up, then down, then up, and then down, until finally it will stop later on. Question is, what is the total vertical height traveled by the ball? So we are talking about the total upward distance and the downward distance. Now, this kind of problem can be solved by applying infinite geometric sequence. Although in reality, the ball will stop bouncing at a certain point, but still this kind of problem can be treated as an infinite geometric sequence because theoretically this ball will not stop because it will always bounce a height, which is a certain ratio of the previous height. But of course, outside forces like gravity and friction will make it stop later on. Okay? Still, we're going to treat it as infinite geometric sequence. Now, what we will do is to separate this 20 and treat this 16 and 16 as our first term. Actually, 16 plus 16 is 32. That should be our first term. A sub 1 equals 32. And since the height is decreasing by 4/5, that means the common ratio is 4/5. So, to find the sum of infinite geometric, it is enough that we know the first term and the common ratio. So, the sum of this infinite geometric series is a sub 1 over 1 minus r, where our a sub 1 is 32 over 1 minus r, 4/5. And this is 32 over 1 minus 4/5 is 1/5, which is 32 times 5 over 1, or simply 5. And this is 160. So this is the sum of the vertical height beginning with 16 and 16, or 32. So to find the final sum, should be 20. Okay, this one which we did not include in our geometric sequence should be 20 plus 160. So the final answer is 180 feet. Therefore, the ball is able to travel a total vertical distance of 180 feet before it stops bouncing.